Welcome, Chem 1. The last time we were together, we talked about oxidation numbers and how to calculate them using basic algebra. Now that we know how to do that, we're ready to start naming ionic compounds. Let's get started. When we're looking at a formula of an ionic compound, hopefully you're starting to recognize that it's broken down into two parts, the cation and the anion. When naming, the first thing we do with the cation is just name it. Cations are typically an element, so if the cation is lithium, we would just write lithium. There are only two polyatomic cations, ammonium and mercury 1. If you look at your polyatomic ion sheet, you'll also notice there are some cations that can have multiple oxidation states, like copper 1 or copper 2. If you're going to name an ionic compound correctly, you would need to differentiate between which copper that would be. You can do this with the Roman numeral naming system, or you can do this with the traditional naming system using "ic" and "us" suffixes. We'll go through how to do this when we get to the examples. The second part of the ionic formula is the anion. If we have a monatomic anion, we're going to take that anion and add IDE to the end. So Br minus 1, that anion would become bromide. And I minus 1 would become iodide. Sulfide, phosphide, oxide would all be the other examples that you see here. Polyatomic ions that are on your list would just be written as they are. So sulfate is just sulfate, and nitrite is just nitrite. But make sure that you are getting the right variation, because there's a difference between nitrite and nitrate. Let's start applying this and walking through examples. The first example we have here is rubidium and then NO2. Rubidium is just a monatomic element, so we would just write rubidium. NO2 is a polyatomic nitrite, and so we would just write nitrite. The next one here, we have copper and we have sulfate. But if we look at our polyatomic ion list, we'll see that there are two different types of copper. This is going to require us to identify the oxidation state of copper. We know that sulfate is a -2. So if we were looking for the oxidation state of copper, it'd be X plus -2 equals 0. That helps us see that copper is a +2. And if you look at your polyatomic ion, a copper with +2 can be written two ways. You could write cupric sulfate, or you could write copper 2 sulfate. Both of them are correct. I prefer the Roman numeral. I think it's easier to remember, but that's how you would write that correctly. If you don't include the Roman numeral, it would be counted as incorrect. Here's another one. We have iron, which could be two different oxidation states. We'll call that X. And then we have two hydrogen sulfates. If you look up the charge of hydrogen sulfate, you will see that it's a -1, meaning that iron has to be a +2. We could call that ferrous or iron 2. You could call this bisulfate or hydrogen sulfate. They're both names for this polyatomic anion. Here's another example. NH4 is the polyatomic cation ammonium. We would just write ammonium. And then PO4 is the polyatomic anion phosphate. So we would just write phosphate. Notice there's no need for Roman numerals here. Ammonium only has one charge, +1, and therefore we can just write it down. Here's aluminum sulfite. Aluminum is only ever a +3. We do not need to clarify with a Roman numeral. Here is lead. If you look at your polyatomic ion list, you will see that lead can be +2 or +4. Carbonate is a -2, and there are two of them. This tells us that lead has a +4 oxidation state. So lead 4 carbonate or plumbic carbonate. Either one would be correct. Here's iron 3 chloride, because each chlorine is a -3, which means this iron has to be a +3. And here's stannic iodide, or tin 4 iodide. Each iodine is a -1, and therefore this tin has to be the +4 kind. What we have here is some more challenging names. BO2 is not on your ion list, but you know that BO3 with a -3 charge is borate. So if we have one less oxygen, that makes it borite. Same thing is going on with nickel hypophosphite. We know that phosphate is PO4. Phosphite then would be PO3, and then hypophosphite would be PO2. This next one is pretty tricky. It looks like it might be barium oxide, but barium is a +2, and that means each of these oxygens have to be a -1. The only way that that can happen is if this is a peroxide. Peroxide is the only time when oxygen takes a -1 oxidation state. If oxygen was a -2 and it was just barium oxide, it would just be 1 barium and 1 oxygen. But that's not what we have going on here. Finally, we have cobalt-3 bromate. Bromate is a -1 charge, which means this has to be cobalt-3. This is another thing that's just going to require some practice. Get comfortable with calculating the oxidation states of cations that could have multiple charges. Keep working hard. Let me know if you have questions. We will see you later.